Hi, I'm Dr. Kamakshaya. In this video, I'm going to talk about chi-square goodness of fit test. So, what is this goodness of fit test? It just try to test the whether the differences across the categories are statistically significant or not. I've got some hypothetical data of some certain unknown KF. Here, there are sales information related to 4 different categories of the products being offered from that KF, namely espresso, latte, cappuccino, mocha, something like that. Okay, this is the respective figures of sales. Now the hypothesis, though there are some certain differences across the sales, but they are more or less same, something like that. That is the null hypothesis for goodness of fit test. There are different ways to formulate the hypothesis, but I would like to formulate in this way. Now, what are we going to do? We have to, in order to perform the chi-square test, we need to calculate a particular statistic called chi-square statistic, and the formula for this statistic is going to be OI minus EI, O minus E divided by O minus E whole square divided by E. So this is actually a ratio. We need to sum up all those ratios for different categories of the product, and then compare that statistic with the theoretical value, which means critical value of the chi-square statistic, and then take the decision whether the decision is that whether we are accepting the null hypothesis or rejecting the null hypothesis, something like that. So let us do these calculations. So first I need to calculate E, which is expected frequency, which means sales. Now the expected frequency is nothing but number of sales. These are actually the number of sample respondents. This information related to 200 consumers of this KF, something like that, divided by number of categories of products. There are 4 categories here. Now I need to freeze this cell because that's the value for that cell is not going to change across the categories. So if you press F4, that will there will be an additional dollar sign in the cell for that cell address, which means you are freezing that cell. Now I can fill down, Control D, so that that value will be filled down in the same column. Now let us calculate O minus E, which is just a subtraction. O is the observed frequency, which is 50 here, minus E is 50. Now again fill down. Now let us square this, O minus E whole square. This is actually a hat symbol, which is one of the keys among the numeric keys at top of your keyboard. So what are we going to do? We just raise to 2. Each value is raised to 2. Now fill down. Now finally we are going to divide this mass with E. So what are we going to do? So this O minus E square, O minus E whole square divided by E. Now again fill down. So now the calculated chi-square value is 13, and the critical value for 3 degrees of freedom. What is this 3? We have 4 different categories of product. 4 minus 1, n minus 1 is going to be 3. So you have to fetch the tabular the critical value of chi-square from the chi-square table. Now the critical value is 7.815, which is far below the calculated value. So which means we are rejecting the null hypothesis. So what is the null hypothesis? The sales of these 4 different products, more or less same, is rejected. So the actual differences are statistically significant. Thanks for watching this video. Stay tuned for the new content.